You are well acquainted with the solar system, our cosmic backyard, where planets, moons, and endless other objects orbit the sun. All of this is being fostered by the sun, which functions as a large campfire in the center of it all. It all started about 4.6 billion years ago, when a gigantic cloud of gas and dust collapsed under its own weight. As this cloud grew denser and cast into a disk, most of the material collected in the center to create the sun. The remaining particles clumped together to form planets, moons, and other celestial bodies. These young planets would settle into their current orbits over a process that would stretch across millennia, and they would shape the solar system as we know it today. Our solar system has 8 planets, each with unique characteristics because they have solid surfaces. The 4 closest to the Sun, Mercury, Venus, Earth, and Mars, are referred to as the rocky planets. Mars, that may well have harbored life, and Venus, an acidic hell, are 2 examples. Beyond Mars, a belt crowded with thousands of asteroids is like the detritus from the solar system's early days. Beyond the asteroid belt, we arrive at the giant planets: Jupiter, Saturn, Uranus, and Neptune. These massive, gas-dominated planets with shrouded and swirling atmospheres. Jupiter, the largest planet of them all, features a gargantuan storm known as the Great Red Spot that has been brewing for hundreds of years. Unlike its eternal neighbor with its rings made of ice and rock, which are famed for their beauty, the 2 coldest planets, Uranus and Neptune, are known as the ice giants and are located far from the sun. But the solar system is much more than just planets. There are dwarf planets such as Pluto too, along with hundreds of moons, giant, icy comets, and countless little, mostly unknown space rocks. Some moons, including Jupiter's Europa and Saturn's Enceladus, have subsurface oceans hidden beneath their icy crusts, making scientists wonder whether they might host life. As immobile as the solar system seems, it's moving at stunning velocities. Like the sun, everything in it is barreling through the Milky Way galaxy. Completing one full orbit every 230 million years. That means the last time Earth found itself in this part of the galaxy, dinosaurs were still around. Exploration of the solar system helps to inform us of where we came from and what else could be out there. The next discovery is always a tweet or a press release away, whether it be from the Mars rovers or the Voyager probes, each bringing more clarity to our understanding of the universe. Who knows? Perhaps someday, humans will travel beyond Earth and visit these far-flung worlds in person. Formation of the solar system. We already told you the history of our solar system starts about 4.6 billion years ago, when a massive gas and dust cloud floating in space was abruptly disturbed. Scientists suspect this was likely due to the shock wave of an exploding star or supernova nearby that shook the cloud awake. The cloud later collapsed under its own gravity, with material drawn inward, which was the precursor to where our sun and planets formed. As it collapsed, the cloud started spinning faster and flattening into a disk. This was the solar nebula, the swirling birthplace of everything in our solar system. In the middle of this disk, where most of the matter collected, the pressure and heat were so great that nuclear fusion started. It lit up the sun, which formed out of all that material and ended up being the centerpiece of our solar system, keeping everything in orbit due to its incredible gravitational force. As the sun began to form, the remaining material in the surrounding disk began sticking together, forming little clumps. These clumps collided and merged with each other, forming progressively larger objects. This so-called accretion formed planets, moons, and other celestial objects over the course of hundreds of millions of years. The more massive objects drew in more material because of their greater gravity, which then formed into the structures of the planets as we know them. But not every region of the solar system formed into planets. The material in some places wasn't dense enough to create a full-sized world. The asteroid belt between Mars and Jupiter is especially glaring that way. It's littered with rocky remnants that didn't form a planet. Farther out, at the fringes of the solar system, debris that didn't coalesce into planets became comets, meteoroids, and odd bits, the small moons that still zip through space today. This was the early period of violent construction, which led to the organized solar system we know today, complete with revolving planets, moons and asteroids, and innumerable smaller bodies. Billions of years after its birth, the solar system is a dynamic environment, rife with yet more secrets to uncover. Structure of the solar system. The solar system is structured in a way that reflects how it was formed billions of years ago. At its center is the sun, the powerful force that holds everything together with its gravity. Moving outward, we see different regions, each shaped by distance from the sun and the materials that could survive there. Mercury, Venus, Earth, and Mars are the rocky planets closest to the sun. These planets formed in a zone where the young sun's heat was great enough to keep lighter materials, like ice and gas, from accumulating. Consequently, those worlds are small, dense, and have solid surfaces composed primarily of rock and metal. Things start to change beyond Mars. The asteroid belt sits between Mars and Jupiter and is a region of space filled with millions of rocky bits, debris from the formation of the solar system that never coalesced into a full-sized planet. Others, including Ceres, are massive enough to qualify as dwarf planets. Things get interesting farther out, beyond the snow line, where temperatures were low enough for the ice and gas to condense. With the gas giants, Jupiter and Saturn, these giant worlds are mostly made of hydrogen and helium and have thick atmospheres and no solid surfaces. The largest planet, Jupiter, has dozens of moons, and a storm that rotates called the Great Red Spot, and Saturn is well known for a lovely ring system composed of bits of ice and rock. Farther still are the ice giants, Uranus and Neptune. These are slightly smaller than the gas giants, and they host large amounts of water, methane, and ammonia ice that give them a bluish hue. Uranus is also unusual because it spins on its side, while the ninth and last planet, Neptune, has the strongest winds in the solar system. Outside the orbit of Neptune is the Kuiper Belt, a vast ring of icy objects including Pluto, Eris, and other dwarf planets. It's also the source of many comets before they start heading inward toward the inner solar system. Farther still, at the very outskirts of the Sun's influence, is the Oort cloud, a hypothetical spherical shell of frozen debris extending nearly a light year from the Sun. This remote area is thought to act as a storage area for long-period comets that occasionally emerge from the inner solar system. You are within the solar gravitational bubble, known as the heliosphere, that encompasses rocky planets, the asteroid belt, the gas and ice giants, the Kuiper Belt, and the Oort cloud. The arrangement of the solar system with inner rocky worlds that transition to outer icy reaches is a direct consequence of how materials were distributed in its early protoplanetary disk. Today, scientists are still studying its structure to glean more about how planets form and what's beyond our cosmic yard. The Sun. The solar system was formed around a glowing ball of hot gas, the Sun, at its center, which gives life on Earth heat and energy. Perhaps it was one of the stars in the fresh career of galaxy after all, but in our cosmic backyard, the Sun is king, governing everything with its massive gravity. In fact, it accounts for more than 99% of the total mass of the entire solar system, which means that compared to the Sun, all of the planets, moons, asteroids, and comets together can be considered nothing but tiny specks in space. The Sun is an average G-type star, also known as a yellow dwarf, though in reality, its color is more white than yellow. It's a huge ball of hot plasma, primarily hydrogen and helium gas, with a diameter of about 1.39 million kilometers, more than 100 times wider than Earth. Nuclear fusion occurs deep at its core, with temperatures soaring to an astonishing 15 million degrees Celsius. This fusion process involves hydrogen atoms joining to become helium and the release of tremendous amounts of energy. This energy radiates out into space, where it arrives peppered with little packets that we perceive as sunlight, which warms our planet, sustains plant life, and powers Earth's weather and climate. The Sun not only provides light and heat, but its gravity is like the glue that holds the solar system together. All the planets, moons, and other bits of space rock spin around it, held in place by its mighty gravitational pull. But the Sun doesn't only influence planets, it radiates a constant outflow of charged particles called the solar wind. This wind races through space at fantastic speeds and builds a protective bubble known as the heliosphere, which protects the solar system from dangerous cosmic radiation. The Sun is really the power source of the solar system. That's because solar system derives from sol, the Latin name for the Sun. Without it, there would be no planets, no warmth, and no life as we know it. You may only be a standard star in the massive universe, but to us, you are our everything. The 8 planets of the solar system. There are 8 distinct planets in the solar system, and each one is unique in atmosphere, makeup, and mystery. They are all in orbit around the Sun and are classified into two main types: the four inner rocky planets, Mercury, Venus, Earth, and Mars, and the four outer gas and ice giant planets, Jupiter, Saturn, Uranus, and Neptune. Here's a deeper look into each of their planets and what makes them special. Mercury. Mercury is the closest planet to the Sun and the smallest in the solar system. It is slightly bigger than Earth's moon, and like the moon, its surface is marked by ancient craters from asteroid impacts. Mercury has such minimal atmosphere that there is nothing to trap the heat, resulting in remarkable temperature changes. Daytime highs can reach up to 430 degrees Celsius, while nighttime temperatures plummet to minus 180 degrees Celsius. The planet has no moons, no weather, no substantial atmosphere, only a dark, barren, rocky landscape that has potentially remained the same for billions of years. Mercury, maybe not being so nice and hospitable, at the same time is the fastest, which takes only 88 Earth days to complete a single trip around the Sun around, making it the fastest planet in the solar system. Venus. Venus is often referred to as Earth's twin because it's similar in size, mass, and composition. But it's really a world of extreme heat and crushing pressure. The planet's dense atmosphere consists mostly of carbon dioxide, which traps heat in a runaway greenhouse effect and makes Venus the hottest planet in the solar system. Its surface temperature exceeds a blistering 465 degrees Celsius, too hot to melt lead. Thick, yellowish clouds of sulfuric acid blanket the entire planet, reflecting sunlight and making Venus one of the brightest objects in our sky. Unlike most planets, Venus has a retrograde sideways rotation and rotates so slowly it has a day longer than a year on Venus. With no moons, toxic atmosphere, and volcanic topography, Venus is a harsh, unforgiving planet that scientists continue to study for insight into how the climates of planets evolve. Earth, the blue planet, and our home. In the whole solar system, Earth is a truly unique place, as it is the only known planet which can sustain life. Earth is significantly different than the other planets. It has liquid water oceans, a breathable atmosphere, and a protective magnetic field from dangerous space radiation. The planet's atmosphere consists primarily of nitrogen and oxygen, which sustains humans, animals, and plants. Earth's distance from the Sun puts it in the habitable zone, the area where temperatures are just right for the water to be present in liquid form. Earth has one large moon as well, which helps stabilize the planet's tilt and governs ocean tides. Earth's plate tectonics, volcanic activity, and erosion over billions of years have altered the landscape to the variety we have today. Mars. Mars, aka the red planet, is red because iron oxide, rust, is found on its soil. It is a cold, dry desert world with a thin atmosphere, largely composed of carbon dioxide. Mars features some of the most extreme landscapes in the solar system. Olympus Mons, the largest volcano in the solar system, Valles Marineris, a canyon system so long it could extend across the entire United States. Today, Mars is dry, but powerful evidence indicates that billions of years ago, rivers and lakes ran across its surface. There is still the potential for underground water, which has led scientists to speculate that life may have formed in the past, or even does today, in microbial form. Mars has two small moons, Phobos and Deimos, thought to be captured asteroids. Mars continues to be one of the most studied and most exciting future human destinations, with multiple rovers and orbiters exploring the planet. Jupiter, the giant of the solar system. Jupiter is the largest planet in the solar system, over 2.5 times more massive than all the other planets combined. A gas giant, Jupiter does not have a solid surface and is predominantly composed of hydrogen and helium. Its spinning atmosphere is crisscrossed with powerful bands of clouds, including the planet's best-known feature, the Great Red Spot, a massive cyclone that has blown for at least 350 years. Jupiter also has a massive family of moons, at least 95 discovered so far. The 4 largest, called the Galilean moons, are all worlds unto themselves. Ganymede is the largest moon in the solar system, and Europa hides an ocean beneath its icy crust, while Io is the most volcanically active body in the solar system, and Callisto is one of the most cratered bodies in space. Jupiter is also home to faint rings as well, but nowhere near as bountiful or visible as Saturn's. Saturn, the ringed wonder. Saturn is one of the most easily identifiable planets due to its beautiful ring system, made up of billions of small particles of ice and rock. Saturn and other planets have rings, but Saturn's are the largest and brightest. Like Jupiter, Saturn is a gas giant predominantly of hydrogen and helium, and does not have a solid surface. It is also the least dense of planets. If you could find a bathtub large enough, Saturn would float in water. The planet has more than 100 moons, the largest being Titan, bigger than Mercury, and with a dense atmosphere and lakes of liquid methane. Another moon, Enceladus, hides an ocean beneath its icy shell and fires water geysers into space. The possibility of life there, making it one of the most tantalizing places to search. Uranus, the tilted ice giant. Uranus is a bizarre and enigmatic planet. It stands apart from other planets in that it rotates on its side, tipped at almost 98 degrees, probably a result of a huge collision in its history. So extreme is that tilt that each pole enjoys 42 years of non-stop sunlight, followed by 42 years of dark. Uranus is an ice giant with a lot of water, methane, and ammonia ice mixed in the atmosphere. Uranus's pale blue-green color comes from the methane. It has dim dark rings and at least 27 moons, with Titania and Oberon as the largest. One of the least explored planets in the solar system. The coldest planet in the solar system, Uranus, is poorly understood, with only a single spacecraft, Voyager 2, visiting it. Neptune. Neptune, which is an ice giant like Uranus, and the farthest planet from the Sun, is a darker shade of blue. It is also home to the fastest winds found in the solar system. which can reach speeds of up to 2,000 km per hour. When compared with a hurricane on Earth, this speed is much faster than even a Category 5 hurricane. Neptune's atmosphere contains huge storms, like the dark spot, that wax and wane over long periods of time. The planet has 14 known moons, its most interesting being Triton. Triton has a retrograde orbit around Neptune and is believed to be a captured Kuiper Belt object, and this moon has nitrogen geysers that are active, one of the solar system's coldest and most popular worlds. Moons, natural satellites. Moons, or natural satellites, are just as compelling companions for planets, as they orbit the planet just as the planet orbits the sun. There are heaps of moons in our solar system. Over 200 have been found, with many more to come. These moons range in size and shape, from small, irregular rocks to massive, planet-like worlds. Not all planets have moons. Mercury and Venus have 0 moons, and Earth has only 1, our well-known moon, which exerts a huge influence on our planet by stabilizing Earth's tilt and causing ocean tides. Earth, in contrast, has the single large moon, while Mars has 2 puny and oddly shaped moons, Phobos and Deimos, thought to be captured asteroids. Far more moons are held hostage by gas giants across the solar system. Jupiter and Saturn alone boast dozens of moons, including the largest moons in the solar system. Even Uranus and Neptune each have more than a dozen moons. Some of these moons are huge. Jupiter's Ganymede and Saturn's Titan are even larger than Mercury. These moons formed with their parent planets, whereas the smaller, strangely shaped ones might be captured space objects. Moons aren't all barren rocks. They can be quite geologically active. One of Jupiter's many moons, Io is the most volcanically active body in the solar system, and dozens of volcanoes are oozing lava across its constantly changing surface. Down at the other end of the solar system, Europa, another moon of Jupiter, and Enceladus, a moon of Saturn, carry secret oceans under their icy skins. In fact, Enceladus actually blows water geysers into outer space through fissures in its outer crust. These moons harbor subsurface oceans, making them some of the most promising locations in the solar system to look for alien life. And while some moons are merely captured rocks of space, others are worlds in their own right, with more going on inside and outside than some planets. From the well-known visage of our own Earth's moon to the icy, obscured waters of Europa and Enceladus, moons wash a fantastic added dimension of diversity and interest onto our solar system. Asteroids. Asteroids are little, rocky bodies left over from the early stages of the solar system's formation. Rather than coalescing into a planetary body, the material forming those space rocks never became a planet. Most of it, in fact, is located in the asteroid belt, a wide ring of debris between Mars and Jupiter. This belt includes more than 1 million asteroids, from little boulders to the largest of the bunch, Ceres, which is large enough, 940 km across, to be considered a dwarf planet. The reason these rocks never came together to form a proper planet is the immense gravity of Jupiter. It kept agitating the region so that the asteroids never tidally grouped together. So rather than a world, we have a smorgasbord of rocky debris orbiting the sun in their own paths. There are many different types of asteroids. Most are lumpy and bumpy, pockmarked by collisions over the ages. Some asteroids are also accompanied by tiny moons. And a few even exist in a binary form, where two asteroids orbit each other like a miniature system. The main asteroid belt is the largest such population, but there are other groups of asteroids. Trojan asteroids follow Jupiter in the same orbit, and near-Earth asteroids can have encounters close to our planet. On rare occasions, an asteroid strikes a planet, sometimes with significant results. About 66 million years ago, the dinosaurs were wiped out, scientists believe, and an impact from a 10-kilometer wide asteroid certainly played a role in their extinction. It's why research into asteroids is important, as it not only helps us better understand the early building blocks of the solar system, but also provides us with the ability to track potential major impact threats to our planet. Now, space agencies worldwide monitor near-Earth asteroids and even send out missions, such as NASA's OSIRIS-REx, to gather samples and study ancient space rocks more closely. The solar system is especially important to us because it is our cosmic address, the only planetary system we know of that contains life. And the solar system is tremendously important for understanding how life began and what conditions may allow it to exist elsewhere, because Earth is still the only place we have found life in the universe. Studying the planets, moons, asteroids, and comets that exist within our solar system can give scientists insight into how planets are formed, how environments develop, and what makes a world habitable. More than Earth, the solar system is a natural laboratory for studying different kinds of planets, from the searing surface of Mercury to the frigid seas under the crust of the moon Europa. No single world is like another, and each teaches us important lessons about geology, atmospheres, climate, and planetary evolution. By examining these differences, scientists formulate theories for how we understand under which conditions other planets, and there are plenty of them about, can be classified as exoplanets orbiting its nearest star. This understanding is crucial in the quest for alien life, in that it allows us to determine which far-off worlds might possess the necessary ingredients to harbor it. Searching the solar system, the ultimate science. Game science is not just discovery, it is also a practical and inspirational value. Spacecraft have visited all of the major planets over the years, as well as many moons, asteroids, and comets, from Mars rovers placing their feet on the surface of another planet to telescopes beaming back breathtaking images of stellar nurseries and black holes. These missions have led to stunning photos and revolutionary new discoveries, expanding our understanding of space and inspiring new generations to look up and out from the confines of our planet. Space exploration fuels technological improvements, so new technologies that are eventually useful in everyday life are developed, ranging from GPS systems to medical imaging. Because these ancient objects are remnants of the early solar system, closely studying them is crucial, and they help us devise strategies for keeping Earth safe from future collisions. Learning how to find and redirect a potentially dangerous asteroid could someday avert a catastrophic impact, similar to the way an asteroid impact helped wipe out the dinosaurs millions of years ago. Ultimately, the solar system is more than just planets rotating around a single star. It's our neck of the woods in the universe, in a place that's full of wonders and discoveries. Understanding how it formed, how it functions, and whether or not it is home to life advances human knowledge of both the universe and of our species. And the more we learn, the more we recognize we are a small part of something much larger than ourselves, a giant and expanding universe waiting to be discovered.